Hello everyone. Alright. How's everyone doing? Alright, let's get to work. So welcome to the third assignment, Convolution. Oh yeah, let's get to work. Welcome everyone. Actually, let's pause this. There we go. To the third assignment, computer assignment 3 for EE360, the discussion portion of the class. We'll be going over convolution and just the second part of the assignment. It's going to be a very short video, so hopefully it makes you more informed or less confused or more confused. I don't even know. To go in brief, the first half of the assignment, pretty simple. I did do edits, not to this part. I did edits to the second half. Exercise 1, draw block diagrams. Note you're gonna have 3 unique equations. Don't just give me the direct form 1 block 3 times. Don't do that. There's 3 unique equations. Yes, the y output eventually becomes the same, but there's 3 ways of implementing that output. So, and note this is a state space diagram. And I give you a hint for the top node for the direct form 2 block, so that should be a helpful thing. Number 2, you're looking for the impulse response. Basically, the impulse response is you have this box and you don't know what it does. You kick it, you just hit it and see what it does. Like a ball, you kick it and it does something and then it just slowly dies down. What happens if you kick a ball and it just starts gradually getting faster to infinity, and you're like, that doesn't make any sense. Same thing with your block diagrams. If they go into infinity, then you did something wrong. You probably forgot a minus sign or something. So that's that. This right here is a 0 state response system. So when the input is 0, all the inputs are 0. You just put in states. So this is easy to implement. Note the negative exponent right there. And then this right here is where that hint comes in handy. So don't forget it. Set these little values. Here's a negative exponent. And yep, that's it. I've revised all this. Max ab difference. You're just going to look for the difference between these two systems. If this comes to almost 0, then you did it right. But if you do see a big difference, then something's wrong. Maybe your timing is wrong. So point is, everything should be exactly the same. This over here will generate 3 outputs. All the outputs would look exactly the same. So if you see one oddball, then that's probably the wrong one. So make sure you can edit them. I will be looking for the codes for this and this, but I am grading heavily on this one. So for those who don't have MATLAB, this is a treat. For all these assignments, I make sure to verify you know what you're doing. You're not just like turning in an assignment saying the plots are correct though, right? Yeah, but I'm looking for how you generate the answers. So try to get your money's worth. Convolution, not that bad. I did have a little demo for you. So convolution, what you're going to be implementing in this class, in this assignment, is not a block diagram the way we've been doing it. You're going to try and mimic convolution. So all you do is you take an H and an X, you flip X, or you can flip H, but I like X. And then you just multiply all the numbers, so just multiply them all, and then add them all, and then you put them onto a point. Then you just shift, and you can see you shift your X, and you're going to be using the circ shift function for that one. So I do have a little demo for you to see right here. There we go. Solutions. Just kidding. You want to see your solutions right here? Just kidding. No, your solutions right here. Let's generate this graph right here. Let's do this flip. There you go. That's not what he wanted to see. X minus K. So this is what you'll be seeing. So right here we have X, H, and X. So basically this is your 2 unit step responses. So what you do is you flip X, which is this. You flip X. You multiply all these numbers. You just go straight up. just multiply them, and then you add them all. So that's literally what I did right here. So 1 times 0 is 0. Then you add 1 times 1 is 1. And then you add that 1 to all these others, and you just get 1. Then when you use circ 1, x circ 1. And you see that point. Now you have these two multiplied into these two. And then this times this plus this times this gives you 2. And then you keep doing that until you are satisfied with your care. There we go. And you can see our little train just move around. And everything looks fine. And you got to keep going for this one too. Come on. And then you're like, oh, okay, we're just going to keep doing this. And yes, you got to keep going. Keep going, keep going, keep going. And then you're like, wait, hold up. You see stuff coming up here. So then this is where you have to start forcing stuff to go to 0. I can't really show that right here because, well, I have this little for loop. But what you could do is after you shift, like let's say we are here. So you're at this state where this value goes here. You just set the first x circ 1. The first point of the first vector right there is equal to 0. And there you go. That's how you force that number to 0. But when you do this in a for loop, this should be easy. But what you're gonna do, a for loop would look like this. You do for I is equal to 1, 10. Guess actually 1 to 9. X circed. And yeah, that does it for me. Actually, let's do 5. Oh, 2. Why isn't that doing what I want it to do? Circ shift. X flip. So what's going on here? Oh, that's because I gotta flip this. Shift 1, 3. Oh, it's not doing what I wanted to do. X circ 1. Huh. Circ 1. Shift. Yeah, it's okay. But point is, you're gonna be moving that value actually. Dude, now that does what I want it to do. Oh, that's probably why. 1 circ x flip 1, but no, this should work. Come on. Circ shift 1. Oh, okay, I know exactly what's going on. There you go. Oh man. Well, now it's not doing exactly what I wanted to do. Yeah, whatever. But point is, you're going to be implementing that in a for loop. You're just going to be forcing the first point to be 0, and you keep moving that around. You just go back around. The point is, once you get to something like this, force these to 0. Like the reason why.
Narrator dialogue. Oh. Narrator heading level. Exiting narrator.
What was that? I don't even know what's going on. The point is, all these should be 0s right here. So that's how you do the first example 4 right here, or example 5. You build your program right there. No, I want to see vector multiplication. So how do you implement that, knowing that you have let me show you this. So you have h, which is going to be, well, like a couple values. Maybe it might be 5 or 3. So right here I actually have an example right here. Let me run this. This is actually the transpose diagram that I wanted to show you. There we go. Actually, let's not do this. Let's Control R. There we go. So I actually made the transposed code optional. You don't have to do it. I do expect to see 4 completed, but I don't want to see a code for transpose. It's just too difficult. It's just, I couldn't even figure it out. It just took too while. Once I did, it just, yeah, it's just too much. If I couldn't get it in like a day or 3, you won't get it in a week or 5. So make sure you do these blocks, but just do a code for the direct form 1 block diagram using this. So what that means is, so suppose H is a 1 by 3 vector, and X is, well, you can either do a 1 times 1 to a 1 times 3 to get a, well, this is for a direct transpose direct form 2. Actually, I'll go over that right now. It's a little over the place. So this right here is the transpose direct form 2 block. As you can see, this is kind of what it's going to look like. So we're going to try and do this. So what's happening is you have an input. Let's say we have an impulse response. Here's our impulse response. And we throw a 1 into here. So this gets multiplied here. H is 0, 1, 2. So we're looking at the state of this node. So this right here is a state. This entire thing is another state. And the state of this node, like, you know, power. The power or whatever we can see at that node. So when we have a 1 here, this automatically goes into the output. And then this one stays here. This one stays here. Now we shift it up. And then we add this one to the new shifted value, which is this guy right here. And this shifted guy comes from here. So definitely interesting to implement. So I'll show you a quick example. So literally this Q is, here's Q1, the first position, second and third. I'll do this right here for you. Actually, let's do this for I is equal to this. F9, I can't press that. There we go. Let's do this. F9. So this is what you're going to see. So this point right here is going to be here. This right here is going to be here. And then this right here is going to be here. So y of n is automatically going to equal this. And then this shifts from here to here. So let's show, actually, let's do this. Y is equal to the first point. Wait, oh. There it is. Should equal that. But point is, once we get that, now we got to shift our Q. We shifted everything back because what we're doing is we're going up this hill, which I defined as going back. So that's where the shirk shift. So you see these two got shifted correctly. This one came back to the end. We don't like that, so we have to force that one to 0. And then we force it to 0. And darn, I didn't show you that. There we go. No, come on. 9. There we go. That's what I get for pressing the plus sign. There we go. Force that to 0. Now we can do I is equal to 5. Now we take this result, this right here, plus this right here. So as you can see, this minus 2, actually not that one, actually this right here adds up to that one vector we saw earlier. This, there you go. Yeah, I think that's what it is. No, this is something completely different. Sorry, there we go. There we go. Well, that's always 0, so point is, this just goes up. Let me show you the result. There we go. And then you make y of 2 is equal to this, and then it just repeats. Circ shift. Go F9. You have this residue. Make sure you force it to 0. Boom, it's 0, and then you're done. So you just keep that cycle going. There we go. Let me show you that. That's not exactly what I wanted to show you. I didn't show you. The point is, you're gonna be forcing that to Z0. That's for the direct form 2, transports direct form 2. For the direct form 1, it's a different case. You have 8 or in this case 3 gain blocks. These guys right here, these 3 values, and you have to multiply it to x using vector multiplication. So you can either do it, there's one way to do it. So you have h times x, which you can see right here. I'll show you a quick little demo. Oh, wrong. So h times k, or x. So you'll either make this one right here. Let me run that right there. This one is a 1 by 3, and then x, what did I set x as? That's going to be annoying. You want this final result to be a point. So that means this right here has to be a 3 by 1 matrix. So what you could do, and you should try to do this so that you don't get errors, is you should do I don't know, so this is usually what I usually like to do. This is a 1 by 3. It should be a 3 by 1. I don't like that. There you go. X. Yep. A 1 by 3. I to I. Minus 3 to I. So right here, suppose I is equal to 5. So this right here will be the second point to the 5th point. So you're looking at a specific area of the x. So this right here should result in 1 by 3 matrix, and then you can do times h. But this right here is also 1 by 3. This is 1 by 3 times 1 by 3. That doesn't make sense, so you do this. There we go. And then this is a super hint for the direct form 1 block. So yes, you have to modify your x a little bit so that you can do this multiplication. I don't want you to pre-allocate memory for the h's. Don't. This should be left alone. The one thing you'll be messing with is this. So that should ease a lot of pain. And then the convolution function, it's literally really simple. And you already probably saw the answer. There it is, which is this. So yes, this is the answer. However, I want to see that you actually you can get this to look like whatever you implement it in part 1, which is a direct form 1 block code using convolution. Use the circ shift. If you don't use circ shift, I will be minusing a couple points, or just 1, I think. So to get this one right, you have to make sure the output looks right and it matches the first one. So this is one of those problems where like, man, this assignment's hard. Well, actually, not too hard. But point is, I won't be that harsh with grading this time. But I am looking for if you know how to code, and I am definitely looking for if you understand how to do this assignment. So note about this, you'll see some residue. So if that ever happens, you can just do this. YSC YC. Suppose you did this from, you want to get rid of like suppose you have 3 delays, you just get rid of the first 3 points and then you go to end. There you go. You can either do that there, but point is, you're gonna see some residue stuff in the beginning. You can just force them to 0, or actually, yeah, wait. That's right. That's what I was doing wrong. There you go. Boom. So it looks like an impulse or something. It looks like a unit step. So All right, I think that's about it. All right, everyone. Good luck with the assignment. Should be a really simple one. Should be easy to get to. And yeah, all right. Let's play some match music. Go.